Okay, very good morning, students. Today we continue our lecture with the same chapter, Fourier series, but with the new topic, that is the limits for 0 to 2L, or we can say for period 2L. Okay, so period, we start our chapter first with first lecture, that is introduction. Then the example for 0 to 2 pi, right? That is x square pi minus x by 2 whole square, like that. And then we did the example for, this is for continuous function, right? This is continuous function. Then period limits is 0 to 2 pi, but for discontinuous function. Then minus pi to pi, that for continuous, discontinuous, and in this minus pi to pi, even odd, that is neither even nor odd. Okay, this type of example we had done, but today we will do the example for the period that is 0 to 2L. So, or we can say the example of with period 2L only. For that, there is minor changes in the formula, that is Fourier series with period 2L. F of x is equal to a0 by 2 plus summation n1 to infinity an cos n pi x by L plus bn sin n pi x by L. Students, with period 2 pi, we put here cos nx only. But for period 2L, we put here cos n pi x by L. This L is any constant. This L is any constant. So, A0 is 1 by L, 0 to 2L, f of x dx. An is 1 by L, 0 to 2L, f of x cos n pi x by L dx. Please keep in mind, this is the most important thing. Normally students made mistake in this step. They forgot to write cos n pi x by L. They just put cos nx. But if your period, if your limits are 0 to 2L, it means if your given limits is 0 to 1, 0 to 2, 0 to 3, 0 to 4, something like that. Your starting point is 0 and the end point is 1, 2, 3 or any constant. At that time, you have to apply this type of formula. Okay. So, for Bn, formula is 1 by L integration 0 to 2L. For Bn, 1 by L integration 0 to 2L f of x sin n pi x by L dx. Okay, so now clear? Have you any query for this formula? Please confirm in the chat box fast. Have you any query for this formula? Okay. See, everyone, please confirm in the chat box very fast, right? Okay, so we'll move. Good. So we'll move for the example. Okay, so our first question is find Fourier series of f of x is equal to 4 minus x square in the interval 0 to 2. Hence, deduce that pi square by 6 is equal to 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus up to so on. So this is our question. Students, see your period, that is 0 to 2. As I told you, your starting point is 0 and end point is not pi. Your end point is constant term, that is 2. Okay. So at that time, first you have to compare this 0 to 2. So this is 2L. So you have to compare 2L is equal to 2, right? Implies L is equal to 1. Here 2L is equal to 2. This is 0 to 2L. So 2L is equal to 2 means L is equal to 1. And our Fourier series f of x is a0 by 2 summation n 1 to infinity an cos n pi x by L plus bn sin n pi x by L, right? Now, a0. Formula for a0 is 1 by L, 0 to 2L. Here 1 by L and here 0 to 2L. F of x dx. Okay, in every formula 1 by L, but the integral is 0 to 2L, right? So what is our L? As you know, your L is 1. So 1 by 1 is 1. So no need to write here 1. 0 to 2L is 2, which is our given limits. F of x is 4 minus x square dx. Okay. Now, the integration of this 4 is 4x. This one is x cubed by 3. And the limits are 0 to 2. So, by substituting upper limit 4 to the 8 minus 8 by 3. This is upper limit. If I substitute my lower limit, that is 0 minus 0. So after simplification, 8 3 is 24 minus 8. So 16 by 3. This is the value of A0. Okay, any doubt in the value of A0, students? Any doubt? Okay. So, for value of An, no doubt, okay. Value of An, formula of An is 1 by L, 0 to 2L, f of x, cos n pi x by L. Please keep in mind when our limits are 0 to 2L, put here cos n pi x by L. Students forgot to write here n pi x by L. They just do with the cos n x only. Okay. So please keep in mind. Here L is 1. So 1 by 1 is 1. Here 0 to 2. F of x is 4 minus x square, right? Cos n pi x. And the value of L is 1. So no need to write in the denominator 1, right? So into dx. Now applying Leibniz rule, 4 minus x square, keep it same. The integration of cos n pi x is sin n pi x upon n pi, right? Because when we integrate cos nx, then we put here sin nx upon n, because n is the multiple of x. And here the multiple of x is n pi. So we write here n pi minus the derivative of this 4 minus x square, that is minus 2x. Okay, the derivative of 4 is 0 and x square is 2x. So 0 minus 2x, so minus 2x. Now the integration of this sign is minus cos theta will remain same, that is minus cos n pi x upon n square pi square, plus, now the derivative of this minus 2x is minus 2, integration of this is minus sine n pi x upon n cube pi cube, okay, and period limits is 0 to 2. Now substitute upper limit. So if I substitute upper limit here, that is 2 square. So 4 minus 4 is 0. And if we put I here 2, so sine 2n pi, and sine 2n pi is 0. So our first term is 0. Here minus, 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 3 times minus, so minus 2 2s are 4, right? And if I put here 2, that is cos 2n pi, and cos even pi is always 1. So 1 upon n square pi square, right? Now minus minus plus, sine 2n pi is again 0. So this is the value of the upper limit. Now for the lower limit, sine 0. If I substitute here 0, then sine 0 is 0. Minus cos 0 is 1. But here, if I replace x by 0, then 0 into anything is 0. So this one is 0. Minus minus plus, sine 0 is again 0. Okay. So the value of an is minus 4 upon n square pi square. Right? Any doubt? Any doubt? Okay. So for Bn is equal to 1 by L 0 to 2L f of x sine n pi x by L dx, right? Here again L is 1, 2L is 2, f of x is 4 minus x square. Here sine n pi x, value of L is 1 into dx, right? So, okay, now please I want answer from your side, okay? So please raise hand. Who will give the integration of this second step? Yes, Nirmal? Yes, Nirmal.
4 minus x square minus sine n pi
Just,
x upon n pi.
just a minute. 4 minus x square, keep it same. Then integration of sine n pi x is what? Nirmal, integration of sine n pi x is?
Minus cos n pi x upon n pi.
Very good. Minus cos n pi x upon n pi. Okay. Minus. What is the next step? Anyone else? What is the next step? Only 8 students raise their hand. What about us? I will ask from anyone or all of you if you raise your hand or else you not raise your hand. Everyone has to participate for the solution of the example. Okay. What about Aryan Vaghela? Aryan? Aryan? What is the second step? Aryan, give me the answer.
Yes, ma'am.
What is this? What is this? Yes, step.
Just a second.
Aryan, what happened?
Ma'am, I don't know.
What? Sorry? See, students, when I ask and when I teach, please listen carefully. If you have any query, please write in the chat box. Okay? Okay, Aryan, I explain. But if I again request all of you, if you don't understand any step, please ask through chat box. Okay? So, the next step is derivative of 4 minus x square. Derivative of 4 is 0 and this x square is minus 2x. So, just minus 2x. Integration of this minus cos nx is minus sine n pi x upon n square pi square plus derivative of this minus 2x is minus 2. Integration of this minus sine is minus cos. So minus minus plus just cos n pi x upon n cube pi cube. Now the limits are 0 to 2. By substituting upper limit here, 2 square is 4. So 4 minus 4 is 0. Cos 2n pi is 1, but 0 into anything is 0. So 0 here minus, if I put 2 here, then sine 2n pi, sine even pi is 0, minus 2, cos 2n pi, cos 2n pi is 1, so 1 upon n cube pi cube, minus, if I substitute my lower limit, that is 4 minus 0 is 4, and this one, cos 0 is 1, so minus 1 upon n pi. Sine 0 is 0, minus 2, cos 0 is 1, so 1 upon n cube pi cube. Students, this chapter is important chapter for internal exam and G2 exam also. So please do it carefully. If you have any query, feel free to contact me through chat box or through WhatsApp also. Minus minus plus 4 upon n pi. Here minus minus plus 2 upon n cube pi cube. Both will be cancelled. So Vn is equal to 4 upon n pi. 4 upon n pi. Now onwards, I will ask from anyone of you, right? And I will ask for share screen also. So everyone ready with the pen and paper, and you have to do the questions with me simultaneously. It is compulsory for all of you. And make note very well with good handwriting. Bhushan, what is your query? Which minus sign will not come? Okay, okay. Got your query? Okay, Bhushan. So this is the value of Bn, right? Now, the Fourier series f of x is equal to a0 by 2 summation n 1 to infinity an cos n pi x by L plus Bn sin n pi x by L. Now you have to substitute the value of A0, An and Bn. So what is the value of A0? Value of A0 is 16 by 3, right? So 16 by 3, this is minus 4 upon n square pi square. This is 4 upon n. 16 by 3, that is 8 by 3, plus summation n 1 to infinity minus 4 upon n square pi square, right? Here cos n pi x, value of L is 1, and plus Bn, that is 4 upon n pi, right? 4 upon n pi into sine nx. So we keep this as 8 by 3. If I keep minus 4 common, then here minus 4 upon pi square. And if I put summation n 1, 2, 3 up to infinity, then I have cos x upon 1 square, cos 2x upon 2 square, cos 3x upon 3 square, like that. And plus summation n 1 to infinity for the second term. If I keep here 4 by pi and I put 1, 2, 3 up to infinity, sin x upon 1, sin 2x upon 2, sin 3x upon 3, like that, right? Now we want to prove this series only, right? So for that we have to substitute first x is equal to 0. We have to substitute x is equal to 0. If we substitute here x is equal to 0 and our left hand side is 4 minus x square. So our left hand side is 4, here 8 by 3 minus, because see, for 0, all sine 0 will be 0. So here we have just 4 by pi. This cos 0 is 1. So 1 upon 1 square, 1 upon 2 square, like that. Just means some students has doubt here. Rehan, why A0 is 8? Rehan, the value of A0 is what? 16 by 3, right? If I substitute here 16 by 3 and 2, so 16 by 2 into 3. So after simplification, I have 8 by 3. Now clear? Okay, now Priyam, wait. Yes, Priyam, ask your query.
मैम पाई will come ना, cos pi x, cos 2 pi x.
Okay, okay. It's okay. Here, pi, right? Okay. Okay. Now?
Yes.
Okay, okay. But there is no make difference in the answer, because if we take here 0, then all cos 0 is 1 and sin 0 is 0. Third step. Okay, I explain again. Students, I explain this step again. See, this one is clear, right? This is the value of, by putting the value of A0, 16 by 3, our answer is 8 by 3. By putting the value of an, this one, and by putting the value of bn, this one. Now here 8 by 3. See, if I put n is equal to 1, 2, 3 up to infinity in both the term, then for first term, if I substitute n equal to 1, 2, 3 up to infinity for both the term, then for first term minus 4 upon pi square here. So if I put here n is equal to 1, then my first term is cos pi x upon 1 square. For 2, cos 2 pi x upon 2 square. For third term, cos 3 pi x upon 3 square. Okay. And similarly for the second step, 4 upon pi common, and After substituting n equal to 1, 2, 3 up to infinity in the second term, our first term is sine, here sine n pi x, right? So after substituting n is equal to 1, so sine x pi, sine 2x pi by 2, sine 3x pi by 3, like that. Okay. Now, Vivek, now clear your doubt? Okay. Now, so we'll move. After putting x is equal to 0 both the side, right? After substituting x equal to 0 both the side, here 4 minus 0, so 4. All sine 0 is 0 and all cos 0 is 1. So we have here 4 upon pi square. This is by putting x is equal to 0 both sides. So 1 upon 1 square, here 1 upon 2 square, 1 upon 3 square, like that. So after simplifying, 4 minus 8 by 3, so that is 4 3s are 12, 12 minus 8, so 4 by 3 is equal to minus 4 upon pi square, 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus up to so on. If I get for common from both the sides, then I have 1/3 is equal to minus 1 upon pi square, 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus up to so on, right? Similarly, if I put x is equal to x is equal to 2, if I put x is equal to 2 both the side, first I put the lower limit, then I put the upper limit. So if x equal to 2 both the side, then what? See, for x is equal to 2, 2 square, so 4 minus 4 is 0. If I put here 2, if I put here 2, then that is cos 2 pi, 4 pi, 6 pi, and all cos even pi is 1. All cos even pi is 1. All sine even pi is 0. So again, after substituting x is equal to 0 both the side, my left hand side is 0, my right hand side is 8 by 3 minus 4 upon pi square, and in the bracket 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus up to so on, right? Now, if I take here minus 8 by 3, if I keep in the left hand side, this plus sign convert into the negative sign, minus 4 upon pi square, 1 upon 1 square plus 1 upon 2 square, 3 square up to so on. If I keep minus 4 common from both the sides, then I have 2 by 3 is equal to 1 upon pi square, right? 1 upon pi square, 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus up to so on. So students, this is our equation 2 and the previous one is equation 1, and as you see, if I keep minus sign as it is, then from both the equation our right hand side is same. Okay, so by keeping addition of both the equation, by adding equation 1 and 2, by adding equation 1 and 2, so what is the answer? My left hand side is 1/3, here 1/3 and minus 2 by 3, so 1/3 minus 2 by 3 is equal to, what is my right hand side? See, here minus 1 by pi square and the bracket, and minus 1 by pi square, minus 1 by pi square, both the brackets are same. So here minus 2 by pi square, right? And the bracket is 1 upon 1 square, 1 upon 2 square, plus 1 upon 3 square, plus up to so on. After simplification, I have 1/3. Here minus 2 upon pi square. Bracket keep it same, right? So, after simplification, my answer is pi square by 6. That is 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square, like that. So, this is the equation what we want to prove. See, this is the formula, right? What we want to prove. So, first we find the value of A0, then we find the value of AN, then Bn, then after substituting the value of A0, An, Bn, we got this Fourier series, and by substituting the value of n1, 2, 3, we get this one. And for the deduction of the special series, first we substitute x equal to 0 both the side, then we substitute x equal to 2 both the side, and then we get equation 1 and 2. And by adding this equation, finally we deduce the formula. Okay. So, have you any query, students? Have you any query? If yes, then confirm in the chat box. Okay. So, one most IMP example. Find Fourier series of f of x is equal to 2x minus x square in the interval 0 to 3. In the interval 0 to 3, right? Hence deduce pi square by 6 is equal to 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus up to so on. For that, first we have to start with the general Fourier series formula, that is A0 by 2 summation n1 to infinity an cos n pi x by L plus bn sin n pi x by L. Okay, so let's start. As our given integral is 0 to 3, so first we have to compare 2L is equal to 3 implies L is equal to 3 by 2. Please keep in mind, it is most important thing. As our integral is 0 and any constant number, not pi, then first we have to compare our upper limit with 2L and then find the value of L. Now, formula of A0, that is 1 by L, 0 to 2L, f of x dx, right? Now the value of L is what? L is 3 by 2. So we keep 1 upon 3 by 2. So instead of 1 upon 3 by 2, I write here 2 by 3. Any doubt? 1 upon 3 by 2. Then I write here 2 by 3. Both are same. Okay. So I keep here. Then we always compare. Yes. Yes, Devarsh. We always compare upper with 2L only because this is the general, this is, see, as I told you, the formula, see, Fourier series with period 2L, right? With period 2L means 0 to 2L. So the starting point is 0 and our upper limit is 2L. So always we compare 0 to 1 or 0 to 2 or 0 to 3, whatever. We always compare our upper limit with 2L. Okay, now understand? Devarsh, please confirm. Got it or not? Okay. So here L is equal to, see, We always compare our upper limit with 2L, right? Now L is 2 by 3, 0 to 3. F of x is 2x minus x square into dx. So next step is a0 is equal to 2 by 3. Here integration of this x square by 2. So both 2 will be cancelled. So x square minus x cube by 3. X square minus x cube by 3. And the limits are 0 to 3. Okay. So 2 by 3. This is 9. Here 27 by 3. This is for upper limit. Lower limit is 0. So 9 minus 9 is 0. So value of a0 is 0. Now an 1 by L 0 to 2L f of x cos n pi x by L dx. This is 2 by 3. This is 0 to 3. Here f of x is 2x minus x square cos. In the place of 3 by 2 I put 2 by 3. So 2 n pi x by 3 dx, right? So by using Leibniz rule, 2x minus x square, keep it same. The integration of this cos is sine 2n pi x by 3 upon 2n pi by 3. So instead of write upon 2n pi by 3, I write here 3 upon 2n pi, right? Minus derivative of this 2x minus x square is 2 minus 2x. Now the integration of this is minus cos 2n pi x by 3 upon 3 upon 2n pi whole square, and plus minus 2x. This is minus sine 2n pi x by 3 into 3 upon 2n pi whole cube, and the limits are 0 to 3. So 2 by 3. By substituting upper limit, if I substitute my upper limit here, so see 2 3s are 6. 6 minus 9 is minus 3. But if I substitute here 3, then both 3 will be cancelled and sine 2n pi, and the value of sine 2n pi is 0. So my first term is 0. Minus minus plus. Here 2 3s are 6. So 2 minus 6 is minus 4. 2 minus 6 is minus 4. Amog has doubt. Won't we suitable it till 2 instead of 2x? Oh, sorry, Amog, this is by mistake 2x. This is just 2, right? See, the derivative of this minus 2x is minus 2 only, right? Okay. So, for the upper limit, if I substitute here 3, then sine 2n pi is 0. For here, 2 minus 6, that is minus 4. And if I substitute here 3, then cos 2n pi, cos even pi is always 1. And this one is 3 upon 2n pi whole square. And for the last term, for 3 sine 2n pi, both 3 will be cancelled, right, in the third term. So sine 2n pi is again 0. Minus, if I substitute my lower limit, then this is sine 0, and sine 0 is 0. Minus minus plus 2 minus 0, so 2. Here cos 0 is 1. Here 3 upon 2n pi whole square, and sine 0 is 0. So this is the upper limit and lower limit. So after simplification, if I get 3 upon 2n pi whole square common, my remaining term is minus 4 minus 2. So here 2 by 3, 3 upon 2n pi whole square I get common. So remaining term is minus 4 minus 2. So here 2 by 3, here 9, 4 and square pi square. and this one is minus 6. So 3 3s are 9, right? And here 3 and 2 will be cancelled. So my final answer is minus 9 upon n square pi square. This is the value of an. Same way, you have to find value of bn by yourself. And value of bn is 3 upon n pi. Value of bn is 3 upon n pi. And please show last slide. Okay. See, this is last slide. See, this is 2 by 3. This is first term and second term. From both term, we get 3 upon 2n pi whole square common. Okay, so remaining term is minus 4. This plus minus is minus. So minus 4 minus 2. Minus 4 minus 2. Now got it? Now got it, Ishika? Okay. So, your Bn is 3 upon n pi, right? Then you have to substitute your value of A0, An, Bn in our Fourier series. Then after, you have to take x is equal to 0, both the side. Then x is equal to 3, both the side. After substituting x is equal to 0, you get equation 1. After substituting x equal to 3, you get equation 2. And by adding this equation 1 and 2, you get your answer. That is the answer for the deduction which you want, right? So, students, you have to do the remaining example by yourself. If you have any query, then we'll solve in tomorrow's lecture. Okay, thank you. Now, if you want to ask any doubt, then also you can ask.